Imagine discovering that the long-standing culprits behind asthma might actually be clever imposters, setting off a revolution in how we understand and treat this common respiratory woe. But here's where it gets controversial. What if the drugs we've relied on for years are not just ineffective but potentially harmful? Stick around as we dive into groundbreaking research that could flip the script on asthma management. A dedicated team of scientists has uncovered what they're calling Pseudo Leukotrienes, which appear to be the primary instigators of the inflammatory chain reaction leading to asthma, overshadowing the traditional leukotrienes we've blamed for so long. RT's 3 key insights. Unearthing Pseudo Leukotrienes. Experts at Case Western Reserve University pinpointed these novel Pseudo Leukotrienes, substances crafted by free radicals instead of enzymes, that could be the true architects of asthma's inflammatory turmoil. A new direction for therapies. This revelation points to future treatments that might zero in on curbing the free radical oxidation pathway, rather than merely obstructing leukotriene receptors. Picture this: therapies that dial down damaging inflammation while leaving the body's helpful immune responses intact, potentially offering a smarter, more targeted approach. Emerging biomarker for asthma's grip. Levels of these pseudo-leukotrienes soared 4 to 5 times higher in individuals battling asthma compared to those in good health, hinting at their promise as a tool for assessing disease intensity and tracking how well treatments are working. For years, the scientific community believed they had a solid grasp on the biochemical processes fueling asthma. The spotlight was on leukotrienes, molecules unleashed by white blood cells in response to airway irritants or allergens, like pollen, dust, or pet dander. These chemicals kickstart a series of reactions that tighten airways and spark breathing difficulties. As a result, medications were crafted to interrupt this leukotriene-driven chain, helping asthmatics breathe easier. Enter researchers from Case Western Reserve University, who believe these leukotrienes might not be the villains after all. We've identified compounds that mirror leukotrienes in structure but arise via a wholly distinct chemical route within the body, explained lead investigator Robert Salomon, the Charles Frederick Mabry Professor of Research in Chemistry. We dub them pseudo-leukotrienes, and we are convinced they dominate the inflammatory process behind asthma and similar conditions. This breakthrough paves the way for innovative strategies to tackle asthma and perhaps even broader inflammatory ailments, such as neurodegenerative disorders like Parkinson's and Alzheimer's. Supported by funding from the U.S. National Institutes of Health, the study is accessible online as a preprint ahead of its full release in the Journal of Allergy and Clinical Immunology. The fiery nature of oxidation. Traditional leukotrienes form through enzyme-controlled transformations of lipids, those essential fatty molecules in our cells. In stark contrast, pseudo-leukotrienes emerge when free radicals, a type of highly reactive molecule that can be thought of as unstable atoms or groups of atoms hungry for electrons, attach oxygen to lipids. To put it simply, free radicals are like tiny sparks that can ignite chain reactions. Free radical activity resembles an uncontrolled blaze or explosion. Salomon, also a professor of ophthalmology at Case Western Reserve School of Medicine, described, "It's akin to oxygen combining with fuel to produce flames that, if unchecked, spiral out of hand." Individuals with asthma often lack sufficient enzymes and antioxidants, natural defenders that act like firefighters, neutralizing and eliminating free radicals. Without these safeguards, free radicals run rampant, producing pseudo-leukotrienes that mimic leukotrienes by binding to receptors and triggering the same airway-constricting cascade. Popular asthma medications, such as Singulair, work by jamming the receptor like a key that won't turn the ignition. Yet, the true game-changer lies in shifting focus. The breakthrough's real power is in developing medications that halt or regulate the free radical pathway itself, instead of simply clogging the receptor, Salomon emphasized. Inflammation, friend or foe. And this is the part most people miss. Inflammation isn't always the enemy. Our bodies depend on it for crucial functions, such as directing immune cells to wounds for healing, supporting brain development, and even aiding memory formation. Asthma treatments that block leukotriene receptors are sometimes repurposed for off-label use in treating neurological conditions. But here's the controversy. These interventions might inadvertently suppress the beneficial roles of leukotrienes, potentially doing more harm than good. If pseudo-leukotrienes are the real troublemakers and not the leukotrienes themselves, Salomon reasoned, a superior strategy would involve halting the creation of these imposters directly, rather than disabling the entire receptor system. This raises a provocative question. Are we trading short-term relief for long-term health drawbacks by broadly inhibiting inflammatory pathways? It's a debate worth pondering, especially as researchers explore whether this dual nature of inflammation applies beyond asthma. The research journey. Drawing on their extensive background in lipid oxidation and a dash of chemical intuition, Salomon and his team hypothesized the existence of pseudo leukotrienes. They synthesized these molecules in the lab to create detection methods, much like crafting a custom tool to spot hidden clues at a crime scene. To test their theory, they analyzed urine samples from people with mild or severe asthma, comparing them against samples from healthy individuals. The results were striking. Pseudo leukotrienes not only appeared in the asthma group, but their concentrations directly mirrored disease severity. Those with severe or even mild asthma showed 4 to 5 times the levels found in controls. This suggests pseudo leukotrienes could serve as a reliable biomarker, offering a straightforward way to diagnose asthma intensity and gauge treatment success, potentially simpler than current lung function tests that require specialized equipment. Looking ahead, the team aims to explore if these pseudo leukotrienes play roles in other respiratory issues, such as respiratory syncytial virus, RSV, infections and bronchiolitis in infants, or chronic obstructive pulmonary disease, COPD, which affects millions worldwide with symptoms like persistent coughing and shortness of breath. So, what do you make of this? Is it time to overhaul our approach to asthma treatments, or should we proceed cautiously? Do you agree that inflammation has a beneficial side, or is it just a necessary evil? Share your opinions in the comments below. We'd love to hear your thoughts and spark a lively discussion.